Topic that is on everybody's mind, AI. Last week, you said that generative AI and accelerated computing have hit the tipping point. So as this technology becomes more mainstream, what are the applications that you personally are most excited about?
Well, you have to go back to first principles and ask yourself, what is generative AI? What happened? What happened was we now have the ability to have software that can understand something. They can understand why, what is, first of all, we digitized everything. That was, like for example, gene sequencing, you digitize genes. But what does it mean? That sequence of genes, what does it mean? We've digitized amino acids, but what does it mean? And so we now have the ability, we digitize words, we digitize sounds, we digitize images, videos, we digitize a lot of things. But what does it mean? We now have the ability to, through a lot of studying, a lot of data and from the patterns and relationships, we now understand what they mean. Not only do we understand what they mean, we can translate between them. Because we learned about the meaning of these things in the same world. We didn't learn about them separately. So we learned about speech and words and paragraphs and vocabulary in the same context. And so we found correlations between them, and they're all registered, if you will. Registered to each other. And so now we, not only do we understand the modality, the meaning of each modality, we can understand how to translate between them. And so for obvious things, you could caption video to text, that's captioning, text to images, Midjourney, text to text, ChatGPT, amazing things. And so we now know that we understand meaning and we can translate. The translation of something is generation of information, and all of a sudden you have to take a step back and ask yourself, what is the implication in every single layer of everything that we do? And so I'm exercising in front of you, I'm reasoning in front of you, the same thing I did 15 years ago when I first saw AlexNet, some 13, 14 years ago, I guess, how I reasoned through it. What did I see? How interesting? What can it do? Very cool. But then most importantly, what does it mean? What does it mean? What does it mean to every single layer of computing? Because we're in the world of computing. And so what it means is that the way that we process information fundamentally will be different in the future. That's what NVIDIA builds, chips and systems. The way we write software will be fundamentally different in the future. The type of software we'll be able to write in the future will be different, new applications. And then also, the processing of those applications will be different. What was historically a retrieval-based model where information was pre-recorded, if you will, almost. We wrote the text, pre-recorded, and we retrieved it based on some recommender system algorithm. In the future, some seed of information will be the starting point. We call them prompts, as you guys know. And then we generate the rest of it. And so the future of computing will be highly generated. Well, let me give you an example of what's happening. For example, we're having a conversation right now. Very little of the information I'm conveying to you is retrieved. Most of it is generated. It's called intelligence. And so in the future, we're going to have a lot more generative. Our computers will perform in that way. It's going to be highly generative instead of highly retrieval based. Then you go back and you got to ask yourself, now for entrepreneurs, you got to ask yourself, what industries will be disrupted therefore? Will we think about networking the same way? Will we think about storage the same way? Would we be as abusive of internet traffic as we are today? Probably not. Notice we're having a conversation right now, and I don't have to get in my car every question. So we don't have to be as abusive of transformation, information transporting as we used to. What's going to be more? What's going to be less? What kind of applications? Et cetera, et cetera. So you can go through the entire industrial spread and ask yourself what's going to get disrupted, what's going to be different, what's going to get nude, so on and so forth. And that reasoning starts from what is happening. What is generative AI? Foundationally, what is happening? Go back to first principles with all things. There was something I was going to tell you about organization. You asked the question, and I forgot to answer it. The way you create an organization, by the way, someday, don't worry about how other companies' org charts look. You start from first principles. Remember what an organization is designed to do. The organizations of the past where there's a king, CEO, and then you have all these, the royal subjects, the royal court, and then e-staff. And then you keep working your way down. Eventually, they're employees. Well, the reason why it was designed that way is because they wanted the employees to have as little information as possible, because their fundamental purpose of the soldiers is to die in the field of battle. To die without asking questions. You guys know this. I only have 30,000 employees. I would like none of them to die. I would like them to question everything. Does that make sense? And so the way you organized in the past and the way you organize today is very different. Second, the question is, what does NVIDIA build? An organization is designed so that we could build whatever it is we build better. And so if we all build different things, why are we organized the same way? Why would this organizational machinery be exactly the same, irrespective of what you build? It doesn't make any sense. You build computers, you organize this way. You build healthcare services, you're built exactly the same way. It makes no sense whatsoever. And so you have to go back to first principles. Just ask yourself, what kind of machinery? What is the input? What is the output? What are the properties of this environment? What is the forest that this animal has to live in? What are its characteristics? Is it stable most of the time? You're trying to squeeze out the last drop of water? Or is it changing all the time, being attacked by everybody? And so you got to understand, you're the CEO, your job is to architect this company. That's my first job, to create the conditions by which you can do your life's work. And the architecture has to be right. And so you have to go back to first principles and think about those things. And I was fortunate that when I was 29 years old, I had the benefit of taking a step back and asking myself, how would I build this company for the future and what would it look like? And what's the operating system, which is called culture? What kind of behavior do we encourage, enhance, and what do we discourage and not enhance? So on and so forth. And anyways.
I want to save time for audience questions, but this year's theme for View from the Top is redefining tomorrow. And one question we've asked all of our guests is, Jensen, as the co-founder and CEO of NVIDIA, if you were to close your eyes and magically change one thing about tomorrow, what would it be?
Were we supposed to think about this in advance? I'm going to give you a horrible answer. I don't know that it's one thing. Look, there are a lot of things we don't control. There are a lot of things we don't control. Your job is to make a unique contribution. Live a life of purpose. To do something that nobody else in the world would do or can do. To make a unique contribution. So that in the event that after you're done, everybody says, the world was better because you were here. And so I think that to me, I live my life kind of like this. I go forward in time and I look backwards. So you asked me a question that's exactly from a computer vision pose perspective, exactly the opposite of how I think. I never look forward from where I am. I go forward in time and look backwards. And the reason for that is it's easier. I would look backwards and kind of read my history. We did this and we did that way and we broke that problem down. Does that make sense? And so it's a little bit like how you guys solve problems. You figure out what is the end result that you're looking for, and you work backwards to achieve it. And so I imagine NVIDIA making a unique contribution to advancing the future of computing, which is the single most important instrument of all humanity. Now, it's not about our self-importance, but this is just what we're good at. And it's incredibly hard to do. And we believe we can make an absolute unique contribution. It's taken us 31 years to be here, and we're still just beginning our journey. And so this is insanely hard to do. And when I look backwards, I believe that I believe that we're going to be remembered as a company that kind of changed everything. Not because we went out and changed everything through all the things that we said, but because we did this one thing that was insanely hard to do, that we're incredibly good at doing, that we love doing, we did for a long time.
I'm part of the GSP lead. I graduated in 2023. So my question is, how do you see your company in the next decade? As what challenges do you see your company would face and how you are positioned for that?
First of all, can I just tell you what was going on through my head? As you say, what challenges? The list that flew by my head was so large that I was trying to figure out what to select. Now, the honest truth is that when you asked that question, most of the challenges that showed up for me were technical challenges. And the reason for that is because that was my morning. If you were to, chosen yesterday, it might have been market creation challenges. There are some markets that I just desperately would love to create. Can't we just do it already? But we can't do it alone. NVIDIA is a technology platform company. We're here in service of a whole bunch of other companies so that they could realize, if you will, our hopes and dreams through them. And so some of the things that I would love for the world of biology to be at a point where it's kind of like the world of chip design 40 years ago. Computer-aided design, EDA, that entire industry, really made possible for us today. And I believe we're going to make possible for them tomorrow. Computer-aided drug design, because we're able to now represent genes and proteins and even cells now. Very, very close to be able to represent and understand the meaning of a cell. A combination of a whole bunch of genes. What does a cell mean? It's kind of like, what does that paragraph mean? Well, if we could understand a cell like we can understand a paragraph, imagine what we could do. And so I'm anxious for that to happen. I'm kind of excited about that. There's some that I'm just excited about that I know we're around the corner on. For example, humanoid robotics. They're very, very close around the corner. And the reason for that is because if you can tokenize and understand speech, why can't you tokenize and understand manipulation? And so these kind of computer science techniques, once you figure something out, you ask yourself, well, if I got to do that, why can't I do that? And so I'm excited about those kind of things. And so that challenge is kind of a happy challenge. Some of the other challenges, of course, are industrial and geopolitical, and they're social, but you've heard all that stuff before. These are all true. The social issues in the world, the geopolitical issues in the world. Why can't we just get along? Things in the world. Why do I have to say those kind of things in the world? Why do we have to say those things and then amplify them in the world? Why do we have to judge people so much in the world? All those things, you guys all know that. I don't have to say those things over again.
My name's Jose. I'm a class of the 2023 from the GSB. My question is, are you worried at all about the pace at which we're developing AI? And do you believe that any sort of regulation might be needed? Thank you.
Yeah, the answer is yes and no. We need, that the greatest breakthrough in modern AI, of course, deep learning, and it enabled great progress. But another incredible breakthrough is something that humans know and we practice all the time, and we just invented it for language models called grounding, reinforcement learning, human feedback. I provide reinforcement learning, human feedback every day. That's my job. And for their parents in the room, you're providing reinforcement learning, human feedback all the time. Okay? Now, we just figured out how to do that at a systematic level for artificial intelligence. There are a whole bunch of other technologies necessary to guardrail, fine-tune, ground. For example, how do I generate tokens that obey the laws of physics? Right now things are floating in space and doing things, and they don't obey the laws of physics. That requires technology. Guardrailing requires technology. Fine-tuning requires technology. Alignment requires technology. Safety requires technology. The reason why planes are so safe is because all of the autopilot systems are are surrounded by diversity and redundancy and all kinds of different functional safety and active safety systems that were invented. I need all of that to be invented much, much faster. You also know that the border between security and artificial intelligence, cybersecurity and artificial intelligence is going to become blurrier and blurrier. And we need technology to advance very, very quickly in the area of cybersecurity in order to protect us from artificial intelligence. And so in a lot of ways, we need technology to go faster, a lot faster. Okay? Regulation, there's two types of regulation. There's social regulation. I don't know what to do about that. But there's product and services regulation. Know exactly what to do about that. Okay, so the FAA, the FDA, the NHTSA, you name it, all the Fs and all the Ns and all the FCCs, they all have regulations for products and services that have particular use cases. Bar exams and doctors and so on and so forth. You all have qualification exams. You all have standards that you have to reach. You all have to continuously be certified. Accountants and so on and so forth. Whether it's a product or a service, there are lots and lots of regulations. Please do not add a super regulation that cuts across of it. The regulator who is regulating accounting should not be the regulator that regulates a doctor. I love accountants, but I just, if I ever need an open heart surgery, the fact that they can close books is interesting, but not sufficient. And so I would like all of those fields that already have products and services to also enhance their regulations in the context of AI. Okay, but I left out this one very big one, which is the social implication of AI. And how do you deal with that? I don't have great answers for that, but enough people are talking about it. But it's important to subdivide all of this into chunks. Does that make sense? So that we don't become super hyper focused on this one thing at the expense of a whole bunch of routine things that we could have done. And as a result, people are getting killed by cars and planes, and that doesn't make any sense. We should make sure that we do the right things there. Okay, very practical things. May I take one more question?
Well, we have some rapid-fire questions for you as view from the tradition.
Oh, okay. I was trying to avoid that. Okay, all right, fire away, fire away.
Well, your first job was at Denny's. They now have a booth dedicated to you. What was your fondest memory of working?
My second job was AMD, by the way. Is there a booth dedicated to me there? I'm just kidding. I love my job there. I did. I loved it. It's a great company.
Yeah. If there were a worldwide shortage of black leather jackets, what would we be see you wearing?
Oh no, I've got a large reservoir of black jackets. I'll be the only person who is not concerned.
You spoke a lot about textbooks. If you had to write one, what would it be called?
I wouldn't write one. You're asking me a hypothetical question that has no possibility of
That's fair. And finally, if you could share one parting piece of advice to broadcast across Stanford, what would it be?
It's not a word, but have a core belief. Gut check it every day. Pursue it with all your might. Pursue it for a very long time. Surround yourself with people you love and take them on that ride. So that's the story of NVIDIA.
Jensen, this last hour has been a treat. Thank you for spending it.
Thank you very much.